Hello everybody, and let's get started on a real quick easy lesson today dealing with radicals. We know how to simplify them if the index is 2. What are we going to do if it's a little bit more than that? It's pretty easy, and you do have a note guide to go ahead and print off if you'd like to follow along with that. You can easily just go ahead and write these problems down if you'd like. The only difference is the note guide does have a chart, which is easy to reference if you'd like to do that, but I am going to be showing the chart on each page as well. So up to you what you want to do, and let's get started. Alright, so we have a chart here. We're going to use it to help us, and I'm going to explain to you throughout how we're going to use that chart. I'm going to start you off slow with something you know, like in example 1. We have this 32y squared, and we're finding the square root of it. Remember, if it doesn't have a number inside as an index, it's understood to be a 2. So we already know that that means we have to go ahead and break that 32 apart, and you might do like a 216, break that apart to a 4, break that apart to a 2, and a 2. And then we really have underneath here 5 2's. That's how we broke this down. And we know for every 2, you take out 1 because of the square root. And that would mean that we have 4 root 2. So that's something you knew from a previous lesson. And now what does it mean to have this chart here, and how are we going to use it? Well, we're going to be working with an index greater than 2 after example 1 here. And so we're going to use the chart to help us. So I'm going to go to example 1 and show you just how to use the chart with the problem you're familiar with. So let's take a look at what we have here. We're finding a square root. So we're going to go over to our chart, and we're going to be in the column that deals with squares. So the x squared is the column that we want to be in. We're going to follow this column down, and I do not see a 32. So 32 is not a perfect square, and therefore I have to find factors that are. So keeping in mind we have a 32, are there any factors that I've highlighted in orange that when multiplied by another number will equal 32? I am hopeful that you said yes. The 16 times 2 will give us the 32. So 32 really breaks down to 16 times 2. And so what is the square root of 16? You probably know it's 4. I know you know that, but let's use the chart so we can get familiar with it. Slide over that 16 down, slide over in the row to where you have the value of the x, and we would find that that would be a 4. So the square root of 16 is 4 according to the chart, and the 2 does not come out, it's left behind. And we already knew that because we did it a different way up here. What about this y? Well, remember, if you have a square root of something that is a perfect square already, the exponents just cancel, and so the y also comes out. Final answer, so that you can see it clearly, write this down, is 4y root 2. So that's how we do example 1, and again, that should just be a refresher for you. Alright, let me go ahead and clear off my chart here so that I can go ahead and do another problem in example 2. Now, what kind of root are we looking for here? Look at the index, and you can see that in the index we're looking for a 5th root, and so we want to go to the column that has x to the 5th. What we're really trying to find is a number times itself 5 times equals 243. And so let's see if we see that number anywhere. And yes, we see it right, the second one. And we're going to slide over and see what value it ends up equaling. And in the x column here, it looks like it's a 3. So what we've just learned is that 243 has a 5th root of 3. So final answer is simply 3. I want to talk about what that means just to make sure you're clear, and then we can move along a little faster after this. So what I just said to you was 243 can be broken down to 3 times 3 times 3 times 3 times 3. And that really means 3 to the 5th, and we're finding its 5th root, these two cancel, the index and the power cancel, leaving us with 3. And again, we'll use the chart to help us get there. Let's move on to example 3. Looking at example 3, we want to find the 4th root of 512, x to the 4th. So to start off our problem, since it's the 4th root, we'll go up into our chart and look under x to the 4th. We're going to slide down that column and see if we find the 512, and we do not. So we're going to stop right there. We don't want to pass up the 512 value, and we've got 3 numbers to look at, the 1681 and the 256. We're going to see if any of those go into the 512. Start with the biggest number because you always want to find the biggest breakdown that you can. And we find that yes, the 256 goes in there twice. And we slide that over, and it means that 4 times 4 times 4 times 4 is 256. That is what that means. So let's go ahead and break this down. The 512 breaks down to 256 times 2. And the 4th root of that results in that 256 coming out in what again? That 4. You always slide over to the left column and you will find out what the root of that 256 is. It's 4. And we leave behind the 2. And to protect myself from making a careless error and losing points on a test or quiz, I always write in that index before I forget to do so. It's a very common mistake that I see. And finally, we've got to address the x to the 4th, and so it looks like this. What is the 4th root of x to the 4th? And you can easily knock out the index, countering the power, and you're left with just the x. So the x does come out. So the final answer is 4x and the 4th root of 2. Finally, let's go over to example 4, and we have negative 250x to the 6th. And I'm wondering if that negative is something we can deal with, and the answer is, oh yes, we can, because it's an odd index, so the negative can come out. So I'm going to take it out right away, and now I don't have to deal with it anymore. So the negative came out because remember, a negative times a negative times a negative is what? Negative. So that's how it can come out. 250, third. So I've got to go up to the 3 and see if I can take out something from this 250. And as I slide down, I do not see anything that's 250, but I do see that 125, and I know if I double it, that will come out. So let's go ahead and break this apart to 125 times 2. And I know that this 125, the 3rd root of that, let me see what it is. 125, the 3rd root is 5. So now I have a negative 5 sitting on the outside, and the 2 is going to be left behind, so the 2 does not come out. So let's write what we have so far. I'm going to write this index before I forget. I have the 2 underneath the radical because it did not come out. Now I'm dealing with the x to the 6th. And remember that little trick I just showed you, and that is if the index is 3, then I go ahead and I divide the 6 by 3. And what happens there is 6 divided by 3 is 2. So how many times does this x to the 6th come out as a 3rd root? And that is 2. Now in case you weren't sure of what I meant by that, here's your final answer. I'm going to go ahead and map this out again. So this x to the 6th for a 3rd index really means that I can map out 6 x's. Ran out of room, so I'm just going to put it below. And how many groups of 3's do I have? I have 1, 2. Because remember, for every 3 you take out 1. So there you go. That would give me the x squared. Okay, this is our last set of examples, and I just want to continue doing example 5 and example 6 by using the chart. and I want you to get more familiar with it. So I'm going to challenge you to go ahead and do example 5. Think about what column you're going to go into, how to break down that 432. So I'm going to let you press that pause key, come on back when you're finished, and I'll explain the rest of this problem to you. All right, so you're in the x to the third column. You looked there, right? That's the first thing you did. You went to the x to the third column because the index is 3. And then you went to try to find the 432, so your eye went down this column, and it never came across a 432. So you stopped because the 512 surpassed the number, and you said, okay, all right, self, I've got to come up with a factor of 432 that goes in evenly, and is it going to be the 343? Hopefully your eye said no. If not, try your calculator to get to that answer. And then you tried the 216, and what happened when you tried that? You went ahead and found that yes, it worked. So you went and broke it down into 216 and 2. It went in there twice. And what is the third root of 216? You went over to the chart and you looked to see what x value it is, and you got the 6. So the 216, the third root of that is 6, meaning that 6 times 6 times 6 equals 216. That's what it means. And the 2 stays because it does not come out. And now we have to look at the m to the 5th. And again, what little trick did I just tell you? You can go ahead and take that 5 and divide it by 3. And when you take 5 and divide it by 3, you come out with 1. So 1m comes out. How many are left behind? Look at your remainder. And that would be a remainder of 2. For those of you not sure what that means, if I go ahead and write this 5 times, since it has an index of 3, you're taking out groupings of 3. So here's the 1 that you took out, and you have the 2 left over. And this is our final answer, 6m cube root 2m squared. Don't forget to put your index of 3 right inside that little hook. All right, example 6. I want you to give that a try again. Press the pause key, give that a try. Come on back when you're finished and see how you did. Okay, so the 875, well, we're looking for the 4th root, so we're going to go into this column right here. And we are looking for 18, no, we don't have it. So now I start to think about all these numbers here, which one goes into the 1875, and I discover that the 625 went in there, and it went in there how many times? It went in there 3 times. So I'm going to go ahead and break this down to 625 3 times, and the 625 comes out as what? What does it come out as? It comes out as a 5. So that means that 5 times 5 times 5 times 5 is 625. So that came out. I leave behind the 3. It did not go anywhere. And now I'm going to go up here and start taking that 5, dividing it by 4, that 10, dividing it by 4, and what am I left with? Of the C's, it looks like I've got 1 C that came out, and then I left behind 2 C's, since actually 1 C, since I have a remainder of 1. So 4 goes into the 5 one time with 1 remainder. So let me clear that up for you. There you go. And it looks like this. C and C. How about the D? 10 divided by 4 means that I have 2 of them on the outside, and I have how many left over? 4 goes into 10 twice with how many remaining? I hope you said 2. So that you can read this better, the final answer is 5C D squared, 4th root, let's make sure it's in there, 4th root, and 3CD squared. And now for example 7, we really don't even need to use the chart because I know in a previous lesson just recently you were told something very important, and that is if our index matches our power, and you notice that this is an entire group here, then we can cancel out, they balance each other out, and I'm left with x plus 5. It does not get any easier than that. Look at that. Final answer is x plus 5. So when you see the match here on the 7 and the 7, go ahead and just knock them out. X plus 5 is the answer. Now in example 8, we know this is an index of 2, and it's tempting to go ahead and knock these out, but that would make me very sad if you did that, because you forgot one of the important rules here, and that is the fact that this entire thing underneath is one grouping, and you have to treat it as a unit. So can you think of what we can do such that we can get a square on the outside so that we can do this cancellation? Did anybody happen to think M, A, F? So we can break this down. And how does it break down? I'm not sure you need to MAF this because you know that this is going to probably break down to the x minus 3 times x minus 3. That's how it would break down. And that would mean x minus 3 squared. And how did I start this problem? I started it with a square root. So once again, what do you have here? You've got this understood 2. It cancels with your power. Final answer here is x minus 3. Isn't that cool? So old skills always coming into play there with that MAF. If you're not sure how to do that, when you get into your groups and work on the assignment, ask somebody to show you or remind you how to do the factor box or MAF. All right. Let's move on and wrap this up. Alright, so when you're going to go ahead and break down a radical with an index other than 2 and you want to use the chart, look at that index to tell you what column you want to start in. After that, within that column, you want to look for factors of the number that you are breaking down. And then when you're all finished, make sure that you include the index in your answer, and that is a very common mistake for students to leave that index out. And if you did that, you would be saying that it's a square root, and we want to protect that situation by making sure we put that little number inside that hook of the radical sign, and that is called the index. Okay, if you have any questions, of course you can come into class and your questions will get answered.